In this video, we will do an example where we find the 6 trig functions of a triangle. So here's a right triangle, and it's labeled. It says that it has this leg is 10 units, this leg is 8 units. And what we want to do is we're going to label it A, whoops, our little picture, this is A. So this is A, this is B, this is C. So what we want to do is we're going to find the 6 trig functions of angle A. I want to point out a couple things to you. These 3 over here are reciprocals of the ones that are across from them. Reciprocal, remember, means that you're turning a fraction upside down. It's different from what you might think. Cosecant is the reciprocal of sine, not the reciprocal of cosine. And secant is the reciprocal of cosine, not the reciprocal of sine. So it's the opposite of what you would think. Now, in order to do these, we need to know the definitions of each trig function. So sine is side opposite over hypotenuse. Cosine is side adjacent over hypotenuse. Tangent is side opposite over adjacent. And then once you find each of those, you just flip them. You'll flip sine, and that will give you cosecant. You'll flip cosine, and that will give you secant. You'll flip tangent, and that will give you cotangent. So that's what we want to do. Now, if you notice from our drawing, we do not have lowercase side c, which is the hypotenuse. So we're going to need to find that. And we know from previous math that we have the relationship of the Pythagorean theorem. So we're going to need to find that missing side. So c squared is equal to a squared, which is 10 squared, plus b squared, which is 8 squared. So c squared is equal to 164. Now remember, when you're trying to find the square root, in order to find the exact square root, so if we take the square root of both sides, we have c is equal to the square root of 164. If I want to find the square root of 164, I think about the things that will go into 164. And since this is a square root, there's an invisible 2 out there for the root, the index. And for every 2 numbers that you have that are alike when you do the factors, you can pull one out. So 164 is 2 times 82, and 82 is 2 times 41. The 41 can't be broken down, so there are 2 2's, which 2 times 2 is 4, and 4 does have a square root, which is 2. So since there are 2 2's, a 2 gets to come out because that's its square root, but 41 must stay inside, which means that this hypotenuse, the exact value, is 2 square root of 41. So that's the piece that we had that was missing. So let's start over here with our drawing. Now that we have it all labeled, we have 10, we have 8, and we have 2 square root of 41. So what we're going to do is we're going to find the sine of angle A. So sine is side opposite, so that would be 10, over hypotenuse, which is 2 square root of 41. And this fraction can be reduced. 2 goes into 10 5 times. And most books will not let you have a radical in the denominator. It's just not considered standard form, so we're going to rationalize. And what that means is you need to think about how we would get the 41 to come out from underneath the radical. And since this is a square root, we would need 2 41s in order to get it to come out. So we can multiply both the top and the bottom by the square root of 41. And remember, if you multiply by something over itself, that's just a 1. So we haven't changed the value. So on the top, we have 5 square root of 41. And on the bottom, since we have 2 square roots of 41, a square root times itself just comes out from underneath the radical. So this is the sine of angle A. So let's see, cosine of angle A. The cosine is the side adjacent, so that's this one, over the hypotenuse. Again, the fraction can reduce, so we would have 4 over the square root of 41. Can't have a radical in the bottom, so we would rationalize. So we would end up with 4 square root of 41 over 41. And if the 4 and the 41 had anything in common, we could also reduce that one. So let's see now. Tangent of angle A. Tangent is side opposite, so opposite over adjacent would be 10 over 8. And we can reduce that because 2 will go into 10 and 2 will go into 8. So 5/4 would be the tangent. So we have all these answers now. We have sine is 5 square root of 41 over 41. Cosine is 4 square root of 41 over 41. And tangent is 5/4. Now, since we're looking for the reciprocals to do the remaining trig functions, we are probably going to go back, we're going to want to go back to our work here that we had, because if we flip from there, we won't have a radical in the denominator. If we flip from here, we're going to have another radical in the denominator, and we're going to have to rationalize. So let me put that up on the screen. So from our work, sine of angle A, when we were starting, we had side opposite over hypotenuse. And this is what we had from our work. We had 5 over the square root of 41. And we are trying to find the cosecant of angle A. The cosecant is just the reciprocal of sine, so if I flip this, I get the square root of 41 over 5. And that's my cosecant. So if I'm trying to find the secant, it is the flipped version of cosine. And you know, we got 4 square root of 41 over 41, but if we flip that, let me show you what happens. If I flip that, I now have a radical in the denominator, and I'm going to have to rationalize. But if I go back to my work, and I see that cosine was the side adjacent over hypotenuse, and in my work I had this, I can flip from there and I won't have to worry about having a radical in the denominator. So that is the secant of angle A. So this is cosecant. This is secant, where I've just flipped. So for cosecant, you flip sine. For secant, you flip cosine. For cotangent, you flip tangent, and that one was a little easier. The tangent was just 5 over 4, so if we flip 5 over 4, we get 4 over 5. So those are our 6 trig functions of angle A. These would be different if I ask you for angle B, because angle B, so here was angle A, and side opposite was this one. If I said angle B, side opposite would be this one. So we would be looking at 2 different parts of the triangle.